Hi, welcome to my video on the addition formula or tangent. Number 1, learning the formulas for tangent. The addition formula for tan or tangents. The tan of alpha plus beta is the tan of alpha plus the tan of beta over 1 minus tan alpha times tan beta. And the tan of the subtraction of the two angles is the tan of alpha minus beta minus tan beta over 1 plus tan alpha times tan beta. Notice the tan is tan, 1, and tan. That's the same for each of these. But if this is a plus, this is a plus, and this becomes a minus. If that's a subtraction, this is subtraction, this is a plus. So if you have, I have them memorized, and I use them all the time. So this one is the tan, 1 minus tan. So that's a tan. And the angle is 110. And the angle is 110 and a 30. So that means if we have a plus on top, there's a plus in the angle. So this comes out to be the tan of 140 degrees. And we have another one. So this is tan minus tan 1 plus tan 80 times tan 20. Again, that's a tan formula. And the angles are 80 and 20. And again, because that's a subtractor, this is the subtraction of the angles. So this is the tan of 80 minus 20, so that's the tan of 60. Remember, we only have to do as a tan of a single angle. We didn't have to work it out any further. And again, this is the tan. And we have the angles are 5 pi over 6 in radians and pi over 3, because there's a plus there and we have a minus here, so this is a plus. So we simplify that as, let's see, the tan, and we're adding these up, so common denominator is 6, so 5 pi over 6. We multiply by 2 on top, 2 on bottom, that gives us 2 pi over 6. So that becomes the tan of 7 pi over 6. And D again is the tan formula, so this is the tan, and it's a 7 pi over 12, and over 12, make sure there's a 12, and pi over 6. And because that's a minus, then we have a minus and a plus here, so because that's a minus, this is a subtraction of these two angles in radians. So the common denominator for 12 and 6 is 12. So we multiply by 2 on the top, 2 on the bottom, so we get 2 pi over 12 to have the same denominator. So this is the tan. Common denominator is 12, and 7 minus 2 is 5, so that's 5 pi. Again, I could put the brackets or no brackets. So that's, if you've learned, have the formulas memorized. Let's do some more problems. Again, this is the theta here. I get blurred a bit. So we have the tan of alpha plus beta, and we want to find the tan of alpha plus beta if tan alpha is 3/4, tan beta is 1/6. And it says that 0 is less than beta, less than alpha, less than 2 pi. If you do inverse of tan to the negative 1 of 3/4, this angle here for alpha will be larger than beta. And again, you can just check that out, and you might say, well, how come you don't have alpha here and beta here? Well, even though I got 3/4 and a half, this angle of alpha is larger than the beta. And just show you that, okay, turn on the calculator. And so we have inverse tan of 3/4 is 0.75. So that's 37 degrees roughly. And we do the inverse tan of 1 division 6, which is we get a 9. So that's why we have beta is smaller than theta. So let's continue. Tan of alpha plus beta is tan 1. This is a plus, so this is a plus. We got alpha and beta. Because as a plus, this is a minus. This is the tan of alpha, tan beta. And so the tan of alpha is 3/4 plus the tan of beta is 1/6 over 1 minus tan alpha is 3/4 times tan beta 1/6. So we have to simplify this, and to simplify, we do this product here first. So we 3/4 times 1/6, 3 cancels into 6 twice, so we get subtract 1/8. Now the fastest way, what I could do, I could add these on the top and subtract these on the bottom, then multiply by the reciprocal. But the faster way, the LCD for top and bottom is 4 and 6 is 12, but 8, and the common denominator for 4, 6, and 8 is 24. So if you multiply each part of this expression by 24, it makes it easier to simplify. Here we go. Multiply. 4 into 24 goes 6. That gives us an 18. 6 into 24 goes 4. And we get 4 times 1 is 4. 1 times 24 is 24. 8 into 24 goes 3. Gives us a -3. So that's, I said a 4. Look, I put down a 1. And this is, if you have a plus, so that gives us 22 over 21. And notice how I simplified it by multiplying all parts of the expression by 24. The easiest way to simplify a complex fraction. So 22 over 21. Okay, let's try another one. What about the tan of alpha minus beta? Well, the tan of alpha minus beta is tan and a tan over 1. That's a minus, so that's a minus, so that's a plus. So this is tan and a tan, and the angles go alpha, beta, alpha, beta. Again, that's a minus, subtraction, so that's a subtraction, so that's a plus. Now, how do we get tan? So we have the cos of alpha is -√3 over 2, and we got a pi less than alpha less than 3 pi over 2. What I'm doing, I'm writing down this one. So we need alpha. So pi is 180. 3 pi over 2. Pi over 2 is 90, so that's 270. So if I draw the diagram to illustrate this, that's between 180, that's 90, 180, and 270. So that means that alpha is all the way around to here. So that's alpha. Terminal arm goes up to the rotation, perpendicular to the x-axis. So the sine is adjacent over hypotenuse. So in relation to alpha, this is the reference angle right here. So in relation to the reference angle, adjacent is -√3, and the hypotenuse is 2. Notice we have a 2√3, so that's a 1, and it's a negative because there's a y going down negative. So that means that we need tan. So the tan of alpha is opposite over adjacent. So in relation to the reference angle, opposite is -1 over adjacent -√3. So that's 1 over √3, but we have to simplify √3 over 3, √3 over √3. So 1 times √3 is √3. √3 times √3 is 3. So we have the tan of alpha. Now we got to get the tan of beta. But let's see, we have sine of beta is √2 over 2, and it's pi over 2 less than beta less than pi. Again, pi over 2, we know that's a 90. Pi is 180, so that means it's in the second quadrant. So let's draw the diagram again. Draw the circle, and we'll go to the second quadrant and stop there. We're not going to be exact. There's beta, terminal arm, perpendicular to the x-axis, and that's beta, so the reference angle is whatever this angle is. So we sine is opposite over hypotenuse. So in relation to the reference angle, opposite is √2. The hypotenuse is 2. And notice we have again a special right triangle, so that's a √2. So this is a √2, but as x is negative here, so it's a negative √2. So we recognize that √2 over 2 is a 45. So this angle here is a 45, which gives you the √2 over 2. So, but we want what tan is. The tan of beta, tan, again, is opposite over adjacent. Here's the reference angle. Opposite is √2 over the adjacent, which is negative √2. That gives us -1. And so again, the inverse tan of -1 gives you this negative angle here. The angle is going to come out -45, but over here, this reference angle is 45. That means that this angle is 45 is 235, or sorry, 135. So 180 minus the reference angle will give you 135 degrees, but we don't need the angle. We only need tan alpha, tan beta. So let's go back. Tan alpha is √3 over 3 minus tan beta is -1. And we have 1 plus tan alpha is √3 over 3. Tan beta is -1. So we'll simplify this. This is √3 over 3. Double negative is a positive. And we have a 1. We multiply here, we get a negative √3 over 3. So now, again, we have a complex fraction. So the LCD for top and bottom is 3. So we'll multiply each part by 3. Quickest way to do it is to multiply everything by 3. 3 cancels out, we get a √3. And 1 times 3 is 3. 3 times 1 is 3. The 3's cancel out, and I get a negative √3. Normally, to rationalize, we're not supposed to have a radical in the denominator, so we multiply by its conjugate, which is 3 plus √3. Conjugate is we keep the two terms, change the negative to a positive. That's its conjugate. And we multiply, I'll do the multiplication up right here. So √3 times 3 is 3 √3. √3 times √3 is 3. 3 times 3 is 9. 3 times √3 is 3 √3. So I did a FOIL on these two. And now, because they're conjugates, I only got to multiply the first two, 9, minus multiply the last two, which is 3. So if you do the outside and inside, they cancel out to give you 0. And to simplify that, I have 3 plus 9 is 12, plus 6 √3. You add the √3's and √3's, you get 6 √3. And 9 minus 3 is 6. And this is 12 over 6 plus 6 √3 over 6. So this gives me 2 plus √3. And that's find tan of alpha minus beta. So this is the exact answer. Exact answer. I thought I might give a little different question, a little bit more work on the radicals. Perfect question. Reviews all your math skills in a trig. Not all, but most of them. And again, that brings us to the end of the video. And again, if you like the video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.